Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. A very good morning. I would like to bid to my lecturers and my fellow friends. So for today, my name is Harakuma Abrahman. My meeting number is 181644. So I'm going to present my mini proposal for the subject of Biomedical Research Method SBP3002. My title is Association of Different Concentration of Valproic Acid VBA in Chemically Inducing the Reprogramming of Human Full-Term Amniotic Fluid Stem Cells. This is the outline for my presentation. So for the research background, what is actually amniotic fluid? Amniotic fluid is actually a clear yellowish fluid surrounding the fetus throughout the trimester. According to Harvey et al., the function of amniotic fluid is to give protection to the fetus from the trauma, as a protection against infections, source of fluid nutrition for the implications, and also control the temperature. However, in her recent study, Harvey et al. Found that it also reported to harbor a highly potent stem cells. In the history of stem cell therapy, researchers are now finding an alternative source of pluripotent stem cells, which does not involve controversial procedure. So, from the amniotic fluid, researcher has able to characterize amniotic fluid stem cells, and it can be obtained from the gestation period of mid-trimester and also the third trimester. For the mid-trimester, it can be isolated through the process of amniocentesis, and for the third trimester, it can be isolated from the process of artificial rupture membrane or collected during the giving birth. However, does it involve application? Yes, for the mid-trimester, because it involves amniocentesis, which is an invasive procedure which can cause abortion of the fetus. However, according to Manfaat et al. 2015, we have done a research on the rat full-term amniotic fluid stem cells. It showed that rat full-term amniotic fluid stem cells also harbor a good quality of stem cells compared to the mid-trimester. However, the full-term amniotic fluid stem cells does not form a teratoma upon transplantation into another host. Thus, it belongs to the group of broad multipotent stem cells. In recent study, showed that adult cells can be reprogrammed chemically to become induced pluripotent stem cells. Thus, this opened a new path for the human full-term amniotic fluid stem cells to become a highly potent stem cell, which is the pluripotent stem cells. It can be done by chemically inducing the reprogramming of cell by using Valproic Acid, which is VPA. So VPA is actually a cell permeable and also a small molecule which has been affect several pathways. It is actually a histone deacetylase inhibitor which increased efficiency of reprogramming by 100-fold, according to Harvey et al. It can increase the differentiation of the cells in vitro, inhibit the senescence, and also activating the OX4 promoter, thus increase the expression of OX4, which is a pluripotency marker. It can activate the OX4 promoter by activating the histone H3K56. This is my problem statement. A new alternative source of highly potent stem cells should be discovered, and by studying the full-term amniotic fluid stem cell, because it does not involve any ethical issue and also invasive procedure. Besides that, most studies should be done focusing on the reprogramming the cells and also transform it to become the induced pluripotent stem cell, because it harbors a highly potent stem cells. Besides that, lack of study that determine the appropriate concentration of chemical used in the reprogramming of the human full-term stem cell. Thus, a correct or we can say that a good concentration should be found. The objective of my study is to assess the association of different concentration of Valproic acid in chemically inducing the reprogramming of human full-term amniotic fluid stem cells. So, to achieve the objectives, this is my specific objective. I will propagate and characterize human full-term amniotic fluid stem cells from the full-term pregnancy. Also, I will assess the growth of kinetic and population doubling time of the VPA, human full-term amniotic fluid stem cells, and quantify the expression of the pluripotency marker in VPA, human full-term amniotic fluid stem cells, quantitatively and qualitatively. And also lastly, I will assess the ability of the stem cells to undergo cell lineage differentiation, which is differentiation toward the 3 primary germ layer cells. This is my hypothesis. My alternative hypothesis is different concentration of valproic acid has effect in chemically inducing the reprogramming of human full-term amniotic stem cells. For the H0, different concentration of valproic acid has no effect in reprogramming, inducing the reprogramming of human full-term amniotic stem cells. This is the material and my methodology. So amniotic fluid will be collected from the human full-term pregnancy. However, in my study, I will use cryopreserved human full-term amniotic stem cell, which has been done by the previous researcher for her studies. And also, I will culture expand the amniotic fluid stem cell in amniomax media. The samples n equal to 3, and then to achieve my specific objective, this is my procedure. For the monolayer differentiation, after being differentiated into the specific lineage, I will perform ICC immunohistochemistry to confirm the formation of the cells by using the detection of the marker, by using aldehyde staining for the osteogenic, chondrogenic Alcian blue staining, and also the cardiogenic. I will perform immunohistochemistry for the CTN1, CTN2, and also the CNX43. So this is the expected result. The result expected to show a significant difference between the cells at the different respective concentration, as I introduced 0.5 micromolar, 1.5 micromolar, and also 1.0 micromolar of VPA for the cells, for the treatment for the cells. And also it shows shorter population doubling time as exhibit the exhibit reportancy marker, and also undergo trial differentiation. And the data will be analyzed through ANOVA statistical analysis, as 3 groups of sample will be used. So this is my reference. Thank you.